Welcome 8th graders to lesson 10 session 3, which is just more equations that have one variable. So there's only one letter in these. It's for our first problem. This is page 237, by the way. For our first problem, we're just working with x. So confession, I had to read this problem a few times. So reminder, it's okay if you have to read a problem a few times. It's okay if you have to check the answer key for some hints, as long as you're trying to learn it on your own once you get your hint. Okay, so Tariq makes 2 large game mats for a beanbag toss. One mat is a square. If you recall, the square means that each side is the same length. So all of these sides are x plus 3, all of them. That's too tiny. And there's an equilateral triangle as well. Remember, an equilateral triangle, equilateral, equal lines. So each of these is also the same. It's also 3x plus 1. All the sides are the same length of these shapes. The perimeters of the mats are the same. These two mats are going to be equal. What are the side lengths of each game mat? Okay, so these two mats are going to be equal, the square one and the triangle one. But it's not just saying the square, this side is equal to this side. No, no. It says the perimeters of the mats are the same. So the perimeters of these mats. So you need to do the whole perimeter, the whole distance around the outside. Okay, well, how many sides does a square have? There's the one side. There's another side. There is yet another side. Oops, we need a plus sign. I'm running out of room. And there is yet another side. The squares, if you recall, have 4 sides. And how many sides does the equilateral triangle have? How many sides do triangles have? Do you recall? I think you do. So there's one side plus the next side plus the third side. Okay, so there's the perimeter of each of the mats. Okay, now that's a long equation. We need to combine all of these. So what do we have on this side? We've got 1, 2, 3, 4 x's. I'm going to draw my line here. Don't want to leave that out. I've got 4 x's. And then I've got 3, 6, 9, 12. What do I have on my other side? I have 3 x's, 6 x's, 9 x's. And then I have 1 negative, 2 negative, 3 negative. That's a much nicer looking equation. So if you needed help getting to this part, that's totally reasonable. I would like you to, certainly at this point, pause and at least try to get, try this part on your own. I assume you did it. We'll assume you did it. Okay, but you can watch me do it if you want to as well. Okay, I want to, let's see, I can do whatever I want to both sides as long as it's the same thing to both sides. I think that I want to move the 4x onto the right side. So I'm going to get rid of the positive 4x by putting in negative 4x. And I have to do the same thing to both sides. So this one cancels out. And now I have just the 12 on its own. 9x minus 4x. How many x's are left? There's 5 x's left. And I did not touch the negative 3. But I'm going to now, because I need to get that constant, the negative 3, out of there. So I'm going to put a positive 3 to cancel it out, which means I need a positive 3 on this side. 12 plus 3 is 15. And I did not mess with the 5x, so that just gets carried down. Now I need to get rid of my coefficient. I need to get rid of this 5. But if the 5 and the x are touching, that means they're multiplying. So if I'm going to do the opposite of times 5, I need to divide by 5. And I choose to write that as a fraction because I think it looks tidier. So I will write that as a fraction on this side. I need to extend my line, oh no. There it is. Okay, 5 divided by 5, that's 1. I have 1x left. 15 divided by 5 is 3. There we go, that's what our x equals. But it didn't just ask that, it asked what are the side lengths of each game mat. So, wrong button. There we go. So now I'm going to go back up here. And instead of the x, I'm going to sneak in a little 3. So 3 plus 3 is 6. 3 times 3 is 9. 9 minus 1 is 8. So the square has a side length of 6. The triangle has a side length of 8. Because x turned out was 3. Okay. So what's it got in these modulets here? Let's see what the difference is. You can write an equation to model the problem. So they did it slightly differently than I did. Instead of writing out the x plus 3 plus x plus 3, instead of writing that out 4 times, they just multiplied it by 4. That was pretty smart. Yeah, that was a pretty good idea. And then instead of writing out all the sides for this side either, they just put the one side and okay, there's 3 of them, so they multiplied it out. And I'm just scribbling all over my paper now. I'll clean that up. So that's how many sides there are. This is the length of a side. This is how many sides the shape has. This is the length of the side of the triangle. This is how many sides the triangle has. And then they just solved it. This is the same thing we did. We already did that. Go for it. Good for us. Okay, number 1 says, look at the first model. Explain how the equation represents the situation. Well, how does it represent the situation? The side lengths are given to us, right? The side lengths are given. And I know, how many sides does a square have? A square has 4 sides, and a triangle has 3 sides. I was messing with you. And oh yeah, actually, I guess I could put the problem said the perimeters are equal. I never spell perimeter. Perimeter. No. Oh, that's worse. Hang on. Are equal. There we go. That's why we made them equal. The square on one side and the triangle on the other side. Look at the second model. It is the solution of the equation, also the solution of the problem. Well, remember, the solution to the equation was 3. X is 3. But the problem, did they ask what's x? No, they asked what are the side lengths of each game mat. So we had to take it one step further and plug in x for those. So no, it's not. I guess I could type that. Why not? No. We had to calculate, plug in x. That's even better. Plug in the value of x to find the length of each side. What are the side lengths for each game mat? And importantly, how do you know? Don't skip that step. But you can, only because it's practice, be a little bit lazy. The side of the square was 6. The side of the triangle was 8. Okay, so a little bit of laziness there. It's efficiency. We're being efficient. I know because, what was x? X equals 3, and, oops, and I plugged in the value of x. for each side length given. There we go. I like that better than the book answer. Ooh, I haven't got a gold star in a while. Gold star. Number 4, how do you know whether the solution of an equation is also the solution of the original problem? Okay, well, the solution of this equation was not the solution of the problem, right? So how did we know? You have to read the equation carefully to determine what the variable represents. Oh, you know what? I'm going to change the equation. Use your delete button on your pencil. I can read the question carefully. Determine what the variable represents and whether it satisfies the question. So it didn't ask what x was. It asked what the side length of the square and the triangle were. And x was just a part of those. Okay, number 5 is for you to do. Think about what part of this lesson helped you understand it the best, and just put a little note of what that was. And then unpause and do these practice problems with me. Okay, you paused, you answered number 5. Now, ooh, water slide. I love water slides. That's exciting. And, okay, 3 practice problems, just like. Alright, number 6. What page is this? 240. Okay. Number 6. James and his sister save money for a trip to the water park. James saved half the amount that his sister has saved. If they both save $30 more, James will have saved 3/4 as much as his sister. Which equation can you use to find out how much James saved? Okay. So how much James saved is half of what his sister saved. Okay, so all of those equations have this element though. So 1/2 of what his sister saved. Does that work? Okay, so we got that part. This one, I think we can eliminate b though, because 1/2 of x plus 30, no, it's 1/2 of x. So no, not b. That one's eliminated. And if they save $30 more, James will have 3/4 as much as his sister. So 1/2 of what he saved, half of what his sister saved. That's James. And then if he saves $30 more, that will be equal to what his sister saves plus 30 multiplied by 3/4. So I'm going to say it's this one. Let's see, what's wrong with this one? This one doesn't account for his sister will have saved. His sister will have saved, but she will also have had the additional 30. And this one doesn't have the 3/4 at all. So it has to have that 3/4 in there. So it's D. Okay, number 7, now we're going to solve this. We're going to see how much money James has saved in problem 6. And if you recall, James saved half as much as his sister. So X is his sister's savings, and he saved half of that. So I'm going to have to zoom in a bit because they didn't give us a lot of working room here. So I need to be able to write tiny. Okay, so I'm copying over equation from D. That's 1/2 of X, 1/2 of his sister's savings. And he'll save 30 more, and that will be equal to 3/4 when his sister saves 30 more. Okay, line down the middle. And let's see, remember there's 2 different ways we could do this. We could either distribute the 3/4 first, or we could multiply the whole thing by the least common multiple of 2 and 4 to get rid of the fractions first. And I think that's what I want to do because I kind of enjoyed it. Okay, so the least common multiple of 2 and 4 is 4. That's the smallest number that they both go into. So I'm going to multiply all of this by 4. And I'm going to multiply all this by 4. Okay, 4 times 1/2. What's 1/2 of 4? 2x. I multiplied that. 4 times 30 is 120. And then the 3/4 times the 4. Let's show our work for that over here just in case. There's the 4 times 3/4. Just multiply across the top. 4 times 3 is 12. 1 times 4 is 4. 12 divided by 4 is 3x. Oh, 3. Oh, I don't want to do that step yet. 3 times x plus 30. Okay. One more step before we get there. I want to distribute this properly because I don't want to skip a step on you guys. So I'm not going to mess with this side during this step. It's going to stay the same because I'm distributing on the other side. 3 times x is 3x. 3 times 30 is 90. There you go. Okay. Green step. Okay. Now remember, there's lots of different things you can do here once you start balancing an equation. You can move the 120 over to the other side. You can move the 90 over to the side. You can move the 3x. You can move the 2x. I choose move the 2x. So I want to move this 2x over to the other side, essentially. In order to do that, in order to get rid of a positive 2x, I need a negative 2x to cancel it out, which means I need a negative 2x on this side to keep it balanced. So I left my 120 alone. 3x minus 2x is x. Hooray! And then plus 90. Okay. So now, in order to get my x by itself, all I have to do is get rid of that 90, that constant. There's no coefficient in front of my x. So to get rid of a positive 90, I put a negative 90, and now it's canceled out. 120 minus 90. 120 minus 90 is 30. So that's his sister's savings. X was his sister's savings. James saved half of that. So James saved half of 30, which is $15. There we go. So rainbow. We need a purple. Maybe I should have made that in purple. Hang on. That's better. Now it's rainbow. And B, did solving the equation in problem 7a solve the problem? No, it didn't, did it? No, the variable stood for his sister's savings. Represented, I'll put represented. Represented his sister's savings, but James saved half of that. Last problem we're doing together today. The length of Adriana's chicken coop is 3x plus 12 feet. The length of her garden is 16x minus 16 feet. And her garden is 2/3 the length of the chicken coop. So what are their lengths? Okay, I'm going to set them as equal, but we've got our chicken coop. And we've got our garden. Which one of these do we have to multiply by 2/3 in order for them to actually be equal? Which one do we need to basically make smaller in order for them to be equal? Well, the chicken coop's the bigger one. So we're going to multiply the chicken coop length in order to shrink it to match the garden length. Okay, now, do we want to distribute first? I think we do. I'm going to distribute first. Instead of multiplying the whole thing by 3 to get rid of this 3, I'm going to distribute first. Your choice. Okay, so 3 times 2/3 is 2/3 times 3 equals 6/3. 6 divided by 3 is 2x. Going to distribute the 2/3 to 12. 2 thirds times 12 equals 24 thirds. 24 divided by 3 is 8. And those we're adding. And then we didn't mess with this side because we were just distributing. Okay, so now we have our choices to move the 8, move the 2x, move the 6x, move the minus 16. I choose to move the 2x because I want to. So, to get rid of a positive 2x, we're going to put a negative 2x. This cancels out. Now we've just got 8 on this side. And I have to also put a negative 2x on that side so that it stays balanced. 6x minus 2x is 4x minus 16. Now I need to get rid of this constant over here next to the 4x. So to get rid of a negative 16, we're going to put a positive 16. Those cancel out. Put a positive 16 over here, and that is 24. And we didn't mix with the 4x yet. Now we need to get rid of the coefficient that's with the variable. And remember, if they're touching, they're multiplying. So the opposite of multiplying is dividing. I'm going to divide by 4. So now I've got 1x remaining. I'm at the very bottom down here. I've got 1x remaining, just like I wanted. 24 divided by 4 is 6. Okay. So the x is 6, but that's not the length. The chicken coop is 3x plus 12. The garden is 6x minus 16. So I'm going to take out this x, and I'm going to put this other 6 here, because that's what x equals, is 6. I've got to take this x out, and I've got to plug in that 6 there. Okay, what's 3 times 6? 3 times 6 is 18 plus 12. I switched colors, it was going to bug me. 18 plus 12 is 30. So the length of the chicken coop is 30 feet. 6 times 6 is 36. 36 minus 16 is 20. So the chicken coop is 30 feet and the garden is 20 feet. And that's that. Okay. Now remember, it is recommended that you check your work as you go using the teacher edition. This is for studying, not for a test. It's for learning. So when you do your green pages, use what resources you can. Check your work with a calculator. Whatever you need to do to check it as you go to help you learn. And good luck.